Hi, 8th graders. Mrs. Amra here. Today we're going to start our new unit on statistics, and our first couple lessons are going to be on something called scatter plots. So scatter plots, as the lesson summary says here, the scatter plot is it's a graph with basically points scattered or spread out throughout the graph. And then once we learn about scatter plots and how to graph them, what they look like, we're going to talk about their trend or their relationship, how you describe what's happening in those graphs. So you can follow along in your notes, copy them down as you go through them. First question here says the table shows the study times and test scores for a number of students. Identify the scatter plot that corresponds to the given data. So using this table, we have to figure out which of these three graphs matches this table. So what you've learned with graphing points and even in math and science, we have our study times as our X and our test scores as our Y. So for somebody who studied for 14 minutes, they got a 64. So if I look at these graphs, it looks like each line is going by fives. So 14 would be a little bit before the 15 and then up to 64. So that point works. If I check this graph out, 14, that's a little bit too high for 64 because it's above the 65. And then again, here's about 14. That looks like it's too high. So it looks like A is going to be our answer, but let's make sure we check all of them. So the first one, 1763. So again, I'm guessing, or I'm sorry, not guessing, but estimating 17 is a little past 15 to 63. And then I got 24 minutes. So here's 25, 24 minutes, 65 exact. 28 minutes at 72. They got a score of 72. So it looks like the more time they study, the higher their score is. Not a coincidence. 38.76. So 38's a little before 40, and I go up to that guy's about 76. 41.78 over to 41.78, just before the 80, and 46 to 78. So it looks like choice A is our graph. That's a scatter plot. There's points scattered throughout the graph. Now, one thing I want to point out is notice that they did not connect the points. Back a few units ago when we were graphing lines using y equals mx plus b, we connected the points because they were in a nice straight line. These points will not be in a perfectly straight line, and you do not want to connect the points in a scatter plot. You want to keep them scattered, not connect them. All right, so now that we know what a scatter plot looks like, we're now going to look at what they talked about in the notes is the trend or the relationship. The fancy math term we're going to use is correlation. When we talk about what's the correlation, it's the trend or the relationship. What do you notice about the points? So you're going to have one of three answers. Either it's going to be a positive correlation, it's going to be a negative correlation, or there is no correlation between them. So we'll talk about strong and weak in just a minute. So if you look at these 5 graphs, I've organized them. These two are considered a positive correlation. Can you figure out why? Yeah, if you look at this, the points are scattering kind of in a trend. They're scattering up to the top of the graph. Remember how we always look at a graph from left to right? These points are scattering up in a positive direction. These ones are not as close together as those, but they're scattering up. If I look on the right-hand side, these are considered a negative correlation. And that's because, again, if I look at the graph from left to right, see how the points are scattering down towards the bottom of the graph. Those are negative. Again, these points are closer together than this one, but they're both a negative correlation. And then this one, the points are kind of just scattered everywhere. It's not really going up from left to right. It's not really going down. They're just scattered everywhere. So this one has no correlation, or we would say none there. So now that we've talked about positive, negative, and none, let's go back to when we talked about that strong versus weak. So back on the positive side, you notice how these points are closer together than these ones, but they're both considered positive. This has a stronger relationship or correlation. I would say a strong positive connection here because the points are scattered, but they're close together. These points are farther apart. They're not as close together, so this would be a weaker correlation, but they're both positive. So this I could say is a strong positive. This is a weaker positive, but they're both a positive correlation. Same thing with negative. Which one do you think is the stronger negative correlation? Right, it's going to be this one here where the points are scattered together. That's a stronger connection. This would be a weaker negative correlation. Hold on. All right, so now if we move on here, so now we're going to start looking at, is there a relationship? Do you notice a trend? And then if we notice that trend, how could we describe that trend? So the best thing that what I like to do if there's a relationship is when I look at this, when I scatter it from left to right, is I try to draw a line in there. How does that line look? Is it a line? Is it a positive, a negative? What does it look like? So I'm going to use my drawing tool here, if I can get it working. Let's switch my color out. So if I was to connect these, now it won't be perfect because they're scattered, but that line best fits all the data points that they gave. So there was some kind of information, I don't know what it is, right? The first one there, they talked about how much time you study and what your test score is, but this one's just saying X and Y. So is there a relationship? Could you describe a correlation? Yeah, I could. So is there a relationship? Yes. Yes, there is. If there is a relationship, does it appear to be linear? So do you think this line is the best thing I could use to show the relationship? So I would say, yeah, that linear fits in there. All right, so now that we know there's a relationship and that it's linear, since it appears to be linear, is it a positive or negative relationship? So if I look at this, the graph is pointing down from left to right. So we're going to say that it's a negative relationship or a negative correlation. We'll use the math terms here. So part of the reason this is pointing down, that's why it's negative. But if I look at this, as I go from left to right, the X values are increasing. But at the same time as X is increasing, look what happens to Y. It's actually decreasing. It's getting lower and lower. So they're doing opposite things. As X goes up, Y goes down. That's a negative relationship. They're not doing the same thing. So if I look at number 3, let's do the same thing again. Do you notice a relationship? Well, could I draw a line to fit in here? So I'd say something like that is the best way I can fit those points. I can't connect them all, but it's the best I can do. So yes, there's a relationship. Would we say it's linear again? Yes, it would be linear. Yes, linear. So what does it look like if it's not linear? Well, what if we had something like this? That's not, a line's not going to be the best fit. It's going to be something that looks like this. And those really are going to show up in 9th grade. So you're going to see scatter plots again. And you're going to see linear ones, but you're also going to see other nonlinear ones. So we're going to stick with linear here. So since a line is the best way to fit that data, we're going to say positive or negative there. Since it's going up, we're going to say positive correlation. And again, the reason for that is if you look at the X and Y, as they go from left to right, X is still increasing. Yes, some of you are realizing that's always going to happen. So it's really what Y does. Y, if I go from left to right, these points getting higher and higher. This is less than 1. This is at 3. This is at 5. X is increasing and Y is increasing. They're both moving the same direction. So it's positive. They're matching in there. All right, number 4, what do we say about this scatter plot? Could you find a positive, negative, or no correlation there? So again, if I tried to draw a positive, I wouldn't say that necessarily fits the best. Here's a negative. Again, doesn't necessarily the best. My best line, I think, would be something like, switch my color, something like this. So it's not really positive or negative. So what are we going to say? You're right, no correlation. And remember, at any point you can pause to try a question on your own first before I go over it. You can rewind to see something again. You always have those options. All right, number 5, what relationship exists here? So yeah, if you said no correlation, I think I agree with you because there's not really anything happening there. They're just scattered all over the place with no really trend happening. They're just scattered same amount above it as below it. Number 6, what about this one? Yeah, so again, it's one of those weaker ones because they're farther spread apart, but I would say it's a negative correlation. The relationship is a negative correlation that's moving down from left to right in the graph. X is going to be increasing from left to right. It's always increasing. But the Y, right, we started at 80. When I get to the middle, I'm around 40, 50. When I get to the end, I'm around 10, 20. So as X is increasing, Y is decreasing. So it's a negative correlation. They're not moving in the same direction. All right, so now they're going to switch to us not just saying positive or negative, but talk about the relationship. So below is a scatter plot of data on the weights in pounds and the fuel efficiency in miles per gallon for 13 cars. So how heavy a car is, and then how good it is on its miles per hour. So what I'm noticing is the lighter car gets a better gas mileage. then the heavier cars, they get a lower gas mileage or fuel efficiency. So if I drew a line in here, if I drew that line, positive or negative or no correlation, which would you say? So right, we're going to say there's a negative correlation. One reason we can quickly identify that from the graph is because it's the graph, the points are moving down from left to right. But we're going to say here as the weight, whoops, let's fix that. The weight of a car increases. And I'm going to say the weight of the car, that's the X value that we're using. As the weight of the car increases, the fuel efficiency, which is the Y value, it decreases. So they're not moving the same direction, so it's a negative correlation. So negative correlation because X increases and Y decreases. They're not moving the same. All right, number 8. So below is a scatter plot of data on price in dollars, X, and the quality rating, Y, for 14 bike helmets. Write a few sentences describing any possible relationship between X and Y. So just reading that without looking at the graph, to me, I would think that if I paid more money, I'd have a better quality bike helmet in this case. But when I go back and look at this graph, again, if I try to draw that line of best fit, I don't really think I see a positive relationship in there. I think this would be my best line of best fit. Some points scattered above it and some scattered below it. So for this one, I'm going to say that there is no correlation. So if there's no relationship, we can't really say because X increases that Y automatically increases or decreases. So if there's no correlationship, we can say there is no relationship between the price or the cost that you pay and the quality of the bike helmet. Kind of a surprising finding based on those 14 bike helmets. All right, number 9, let's see here. Below is a scatter plot of data on shell length in millimeters for X and the age in years for Y for 27 lobsters known age. Write a few sentences describing any possible relationship. So again, I'm going to start with, what do I notice here? Well, I would draw my line. It looks like there's a positive relationship. So does it make sense to you that the longer the shell is on a lobster, the older it is? Kind of makes sense because you need more time to grow more. So my description, my few sentences, I'm going to start by answering the question. There's a positive correlation. As the shell length increases, the age of the lobster also increases. So they're moving in the same direction. They're both increasing, so it's going to be a positive. All right, home stretch here. Number 10, below is a scatter plot of data from crocodiles on body mass in pounds for X and their bite force in pounds for Y. So write a few sentences describing any possible relationship between X and Y. So before looking at the graph, just what I know about crocodiles, I'm assuming that the heavier they are, the bigger their body mass, the stronger that bite's going to be. But if I look at specifically the data or the research, the findings that the scientists found, they found the same thing that I thought. So now they can prove this to me. So as the body mass increases, 400 pounds has almost 1,600 pound bite force versus maybe a 50-pound alligator that has a bite force, I don't want to say only, but a bite force of around 500. So write a few sentences describing what we see. Well, we see a positive correlation. Make sure I'm not on. There we go. All right, just had to fix a quick glitch on my computer. I think we're back up and running here. So positive correlation because as body mass or the weight of the crocodile increases, the bite force also increases. So positive correlation because as X increases, Y increases. And let's see, number 11 is going to go back to a table. So they're not giving us a graph, but from the table we can still decide if that's a positive or negative correlation. So the data in the table below represents the number of complaints in a restaurant over a set number of weeks. So the first one's going to be our X. So what are you noticing about X? You got 1, 2, 3, 4, 5, 6, 7, 8. That's increasing. And then the number of complaints is my Y. So what's happening as this is increasing? Is this increasing or decreasing, or is it kind of all over the place? So you have 25, 27, 19, 15, 17, 14, 16, 13. So it's not perfect, but I'm noticing that it's having a trend going downward. So there's a couple that it goes up a little bit, but really it's staying around that number and then drops. And then it's going down, it stays around that number and then it drops. And it stays around that number and it drops. So I'd say negative. So which relationship shows when X increases, Y decreases? Right, they're moving in opposite directions. That's going to be a negative correlation. All right, the last two are now going to use, let's make some predictions based on the data that we get from a scatter plot. This is why we use them. So Daniel is processing a large document on a computer. This scatter plot shows how many pages he produced each hour. So I'm noticing the hours are increasing, and then the number of, so 1 hour, less than 5, 2 hours, 5 pages, 3 hours, maybe 6 pages, 4 hours, 10 pages, and 5 hours he jumps to about 18 pages, and it keeps increasing. So I'd say it looks like there's a positive correlation there, if I have to describe the correlation or trend. Okay, using this information, what is the best prediction of the number of pages Daniel can produce in 10 hours. So it's really important to be careful when you're making a prediction. Are they giving you an X value or a Y value? Because it matters where you start. So 10 hours would be right here. So basically, where would the dot fall for this piece here? Let me erase that because it's not a very good line. Where would the dot fall at 10 hours? So what I like to do is actually graph these. So 30 at 30 hours would be right here. 45, well, that's off the graph. 15, that's down here, and then 40 is also off the graph. So which of those four best fits? So if this is a positive correlation, I would say this point right here at 30. So we'll go with choice A. So if I know that the computer is going to work for 10 hours, I should expect it to complete 30 pages. All right, so 13, the local ice cream shop keeps track of how much ice cream they sell versus the noon temperature on that day. So why would they want that? Well, if they need to make sure they have enough supplies and they're going to be able to predict their customers, they want to make sure they have enough supplies to meet the customer's needs and not run out of things. So they can look ahead the weather each week, and they can look ahead about how much they need for their ordering purposes. So the scatter plot below represents their findings over the course of 12 days. So they took the temperature, they had the noon temperature and how much they sold each day for 12 days, and then they can use that to make predictions. So use the graph to determine the best prediction. So best prediction means it's not going to be perfect for the temperature when the store earns $300. So again, $300 is the number they're giving us. That's not your temperature, not even fit on here. Dollars is your sales. So here's your $300 right here. So where would this fit in? Well, the points are hitting around here. So these 2 points are the closest that I have. So the temperature is going to be between, I'd say, 15 degrees and probably 17 degrees. So now if I look at the choices, B doesn't make any sense. They gave us some money, we want a temperature. So which temperature that's left in the 3 choices, I would go with 15 degrees. All right, so that's the beginning of scatter plots.